Hi everyone. So today we are going to see the experiment CNC turning and milling simple programming. The aim of the experiment to write a program and simulate the tool path for the operation involved in the component as given in the figure. Software required CNC software. So let's see the given job. So this is a simple diagram for a CNC part program in a turning operation. So here what we are seeing in this diagram is they are given a simple step turning operation for the workpiece of length 70 mm and maximum diameter of 32. So from this workpiece we have to convert the workpiece into a first step around 26 diameter and the second step diameter is 20 mm. The total length for this step is 20 mm and the remaining step is 20 plus 18, so 38 mm. So this is the given diagram. For this diagram we have to write a part program. So for writing a part program, the part program is divided into three stages. The first step will be, or the first stages will be the initial or starting of the program and main body of the program and end of the program. So now we are going to discuss about starting of the program. Every program must start with G71, G94. So here the machine will run what the command we are going to give. The machine never going to think on its own. So only thing is we have to give the command. Based on the command the machine is going to run. So here the first command what we have given is G71, G94. So which means we are entering the dimensions what we are using in terms of mm. So G71 indicates a metric mode. G94 we have to indicate the feed. For example, the workpiece is going to be fixed in a spindle. So for revolution of the spindle we have to give a command that is G94, which means feed in terms per minute, feed per minute. So second command we have to use is G75, X0, Z0. So here we have to initiate to the home position. So tool in some positions, workpiece will be in some position. So for that, to avoid the collision between the tool and the workpiece, we have to start the program from the home position. So we have sent the tool to the home position. So it is G75 command and X0 and Z0. So here there will be two axes. For example, so this is a workpiece. So this is an axis. So this is called as, this axis is called as Z. This is called as X. So which means diameter we are going to indicate in terms of X value and length of the workpiece we are going to indicate in terms of Z value. So this is, I am going to take it as a reference point 0, 0. If cutting tool will be in this position, the X value is in positive. The Z value in terms of positive. If the cutting tool will move from this position to this position, Z value will be negative. Like this. If this is 0, so this is X. So this is X positive value, and from this point to this point, X will be a negative value. So this is the basic concept behind the part program. So here the first step we have mentioned G71, G94. So this is we are indicating the metric mode and the feed rate. Then G75, X0, Z0. Now we are sending X axis and Z axis to the home position. If we want to change the tool, we have to use M06. So M06 which indicates tool change. So I want the first tool, so I am writing as M06 T1. T1 indicates the first tool. Now I am going to start the spindle which is fixed on, the workpiece is fixed on the spindle. So I am going to start, that is M03. So there is spindle on clockwise direction. We have to give the speed also, that is spindle speed S1500. So the meaning of this command is, now we have initiated the commands, that is metric mode and all the things, and we have changed the tool, and now we have started the spindle to run. The spindle is going to start in a clockwise direction for the speed of 1500 RPM. Now we have to position the tool. For example, I am going to, so this is the workpiece, this is fixed on the spindle, so this is the spindle. I am going to place the tool here. So here, so this is called as this height from this point. This is 0, 0. From this point to this is called as x-axis. This is called as z-axis. So now I am going to place some certain distance. So here, so this is an z-axis. So this is 0, 0, and this is x-axis. So now I want to place the tool from a certain distance from the center point. So this is center point. So this is z-axis. So from this point to this point, z is a positive value. So now I am going to write as z is equal to 5. So which means from this point, the tool is placing from a 5 mm gap. Instead of touching the tool, instead of touching the workpiece, I am going to place here. So we have to find this diameter also. What is the diameter? The total diameter here is 32. So here x is equal to 32. So this point I am going to place the tool. So x value is 32, z value is 5. So I have to write the command based on this value. So I am going to write a command G00. G00 indicates a rapid movement, quick movement of the tool. G90 absolute mode of programming. So here this is the 0, 0. For every dimension, this is the 0, 0 point. This is never going to change. So that is called as principle behind the absolute mode of programming. So 0, the reference point never going to change. So G90, then G55. So this is called as offset value. We are setting 0, 0 to the machine. So we are indicating this is the reference. So here I am stored this value here in G55. So G00 rapid movement, G90 absolute mode method of programming, G55 there is offset we have stored. Now I am going to write x is equal to 32, z is equal to 5. So this is the starting point. Now what will happen? The tool will be placed here. Now I am going to machining. I have to perform a machining operation from this point to this point. So for that we have to see the diagram. So here the total length is 20 plus 18, 38 for the entire dimension. I have to reduce the diameter from 32 to 26. So for that we have to write a program. Now the tool is here. I am going to give some depth from 30 mm. I am mentioning a depth around 2 mm. So from I have to reduce the value, x value from 32 to 30, and I have to mention the path, total distance. So now I am going to write Z01. Z01 indicates the linear method, linear movement. Wherever the cutting tool and workpiece is going to make a contact, while metal removal will take place, I have to use the word called Z01. This command should we have to use. At the same time, if you are using Z01, we have to indicate the feed also. So Z01 rapid movement, linear movement. Then we have to indicate the x value. Now x I have to reduce it from 32 to 30. At the same point, z is equal to 5. What is the feed rate? Feed is 100. Now the tool is slightly undergone the depth for the 2 mm. Now the tool I have to place here for the distance 20 plus 18, 38. So I have to write the command Z01, x is equal to 30, z is equal to minus 20 plus 18, 38. The same feed is going to follow. Now I have to send the cutting tool to the home position again, or some this position. So I am going to write Z00, which means quick fast movement. G x is equal to 32, z is equal to 5. Again I have to cut up to 26. Z01, x is equal to, now reduce 20 to 30 to 28. 28, z minus 38. Again go to the home position or reference point G00, x is equal to 30, z is equal to 5. Again Z01, x is equal to 26, z is equal to, so now here z is equal to minus 38, z is equal to minus 38, the total distance. So now what will happen? The cut, the total length of cut diameter is 26, and from we have reduced the diameter from 32 to 26 for the entire length. Now we have to go for the another step. this we have to perform 26 to 20 for the remaining step. Again we have to follow the same one. So I am going to write Z00, X is equal to 32, Z is equal to 5. So I am sending the home position. Again Z01. Now X is equal to, we have to reduce 26 to 20. So for reduce further 2 mm, so now the X value will be 26 to 24. X is equal to 24. Z is equal to length. Now this is the reference point. We are reducing the length only 20 mm. So Z value is minus 20. Z01 or Z00, X is equal to, again go to the reference point 32. Z is equal to 5. So now, so we have completed up to Z00, X is equal to 32, Z is equal to 5. Already the diameter we have reduced from 26 to 24. Now we have to reduce the value to 22. So Z01, X is equal to 22, Z is equal to minus 20. So that is length. Then again, the cutting tool must be sent to the reference point. So Z00, X is equal to 32, Z is equal to 5. That is the reference point. Then Z0, now it is Z01, that is linear movement. X is equal to 20, Z is equal to minus 20. Now the diameter is reduced from 26 to 20. Z is the distance traveled, that is minus 20 mm. Then we have converted the workpiece into our reference point, our required diagram. Now we have to send the cutting tool to the home position. So G75, X0, Z0, M05 which indicates the spindle stop, and M30, that is the end of the program. Thank you. So next we are going to see about CNC part program in milling. So this is a sample diagram. So this is the total dimension of the workpiece. So this is the length and this is width of the workpiece. So the total length will be 100 plus 20 is 120 plus 40, 160 plus 20 is 180. This is the total length. So here totally 3 axes will be there in terms of milling is concerned. So this is the workpiece and this is the center point for reference 0, 0. So here the first 0 and second 0 indicates X and Y direction, Y axis of the workpiece, and Z will be axis of the tool. So the first 2 axes X and Y indicates the axis of the workpiece, and the Z will be the tool axis. So here, based on this one, we are going to see the part program. So here, this is the workpiece, and I am going to take a reference at this point. So this is 0, 0. So here X0, Y0 and Z0. So from this we have to create one continuous contour milling shaped object. So we have to remove the metal as mentioned in this diagram. So for that, this is the first point, this is the second point, third one, 4, 5, 6, 7, and again we have to come into the first point. So for your reference, so this is the reference now. The axis of this point will be 20, 20. So how in the sense, the x-axis will be 20, and likewise the y-axis will be 20. So here it will be 20, 20. Like that we have to mention all the references for our program. So let's see the part program. Again, it starts with G71 and G94. So G71 indicates dimensions in terms of metric, and we are going to feed the entire dimensions. For example, if we are going to enter 20 now, it indicates the 20 mm. So G71 indicates the machine is going to remember, so the dimensions will be in mm, and G74 feed per minute. So G75, let's go to home position. We are sending all the 3 axes to the home position for our safety purpose. So we want to change the tool based on the given dimension. I am going to take as T1. You may take T2, T3, that is depend on the machine and its tool. M06, so tool change. Now I have changed the tool and I am going to start the spindle. So M03 spindle on clockwise. The spindle speed will be S1500. That is spindle speed 1500 RPM. So now, so just imagine this is our workpiece. So this is the workpiece. I am going to start the cutting from here. So So for that I am going to position the cutting tool here. So this is the reference point, this is our first point, so this is our second point. I have to make a drill, I have to insert the cutting tool into the workpiece and I am going to create a path. So that is the diagram what we have mentioned here. So for that I have to move the tool from the home position to the reference point. So this is the reference point. So G00 rapid movement, G90 that is absolute method of programming. Absolute method of programming which indicates the reference point never going to change. For the entire program this will be the reference point. We may use any reference. I am going to write the program as this is the reference. For your own practice you may change the reference point from any value. You can write a program from this reference point also. If I am going to select the reference point in the center now, based on that the coordinate value will be changed. So G00, G90 that is absolute method of programming, and G55 we are going to save this offset, this reference point to this code. So this is G55 and X0, Y0, Z5. So it indicates, so this is the reference point, the cutting tool will be placed at this point, at the gap of 5 mm the tool will be here. So now I have to move this tool to this point, first point. So G00, X20, Y20. This value is available here. We have to mention this value. So next one, the tool is here now. I have to give a depth. So I am going to select depth is 2 mm. So if this is 0 now, the depth will be indicates in the minus value. So Z01, Z minus 2, F50. That is speed. We have to insert the tool in a slow manner. That's why speed will be very minimum. Now we have to move the machining process. We have to do the machining process. So the second point Z01, X20, Y20. Now I have increased the speed because for giving depth I have reduced the speed to 50. For movement I have to increase the value a little bit. So for that purpose the speed will be 150 mm. Now with the same speed I am going to perform the machining operation. So we should not change the feed value. So the next value will be, now the cutting tool will be here. Now we have to move the tool as mentioned in this diagram. So only we have to mention the coordinate value, that is enough. So here G01, X20, Y110. The next point will be Z01, X70, Y160. Then the next point will be Z01, X110, Y value is 160. Then next value will be Z01, X160, Y110. Z01, X160, Y60. Then Z01, X120, Y20. Then the last point will be Z01, X20, Y20. So which indicates from the starting point it is start machining operation and perform the entire operation. Again we back into the first point. So we have started the cutting operation here. We have mentioned all the coordinates, the metal removal will be takes place, and we have joined the first point. Now we have to remove the tool from the workpiece. So that Z00, that is fast movement, Z value is minus 5. So this is plus 5, not a minus 5. Minus 5 in the sense we have to give a depth. Now we have to remove the value. Here we have mentioned 5. For that here also we have mentioned 5. So it means the cutting tool will be placed above 5 mm on the workpiece. Now M05, so which indicates spindle stop. M30 is the end of the program. So this is the part program, simple part program for the required milling operation. Thank you. So result, thus the program for the given component drawing was written and checked. Thank you.